Okay, this is our third notes for 8.3. 27 through 29 is pages show that quadrilateral is a parallelogram. Okay. And oops, next page. Okay. It says title, show that a quadrilateral is a parallelogram. Theorem 8.7. It says that both pairs of opposite sides of a quadrilateral are congruent, then it's going to be a parallelogram. So for the example here, it says AB is congruent to the opposite side, which is CD. And then that if BC, which is the top of the quadrilateral, is congruent to the bottom, which is AD, if the if opposite sides are congruent, then it's saying that it is going to be a parallelogram. So this is going in reverse order off of the theorems that we've had before. So it's trying to show that if this is the case, then it will be a parallelogram. 8.8 says if both pairs of opposite angles are congruent, then it's also going to be a parallelogram. So that if A is congruent to C, and if B is congruent to D, then it is going to be a parallelogram. Okay. 8.9 says if only one pair of opposite sides of a quadrilateral is congruent and parallel, then this is enough to say that it is a parallelogram. So just one set. So the example here says that if BC is, you can say say congruent first, so I'm going to put the congruent symbol. If BC is congruent to AD, and then BC is also parallel to AD, and that's this little red arrow that I have here on the side showing that they're parallel. If one set is both parallel and congruent, then that is sufficient enough to say that they are parallelogram, that it is a parallelogram. Okay. 8.10 is the last theorem for this section, and it refers to the diagonals. If the diagonals of the quadrilateral bisect each other, which bisect means cut in half, then that will state that it is parallelogram. So for my blank here, we'll write the word bisect. If BD bisects AC, then it is a parallelogram. In our first example, this is my funny looking little basketball goal that they had on the example. It said in a diagram AB and DC represents the adjustable supports of the basketball hoop. So this thing can go up and down based on how high you want the hoop to actually be. It moves. The question is explain why AD is always parallel to BC. Well, if I adjust this little thing going down, then the entire basket shifts down, or I can make it higher and shift it up. So I'm still maintaining a parallelogram how it's rotating up and down. Okay, it's just shifting where it's at. And it says, why is it always parallel? Well, if I move this basket down, is AD changing in length? Is BC changing in length? Are these actually shifting on the goal? Is the goal moving by this shape getting closer together? Or is the whole thing moving? If you've ever seen a basketball goal, this whole back shifts down or it shifts up. So to explain why they're always parallel, I'm going to say that AD is parallel to BC always because AD, the segment AD and the segment BC's side lengths never change. In other words, AD is always congruent to BC. Alright, example 2 says show why KLMN is a parallelogram for this particular sake. Now, to be able to show that this is a parallelogram, I'm referencing all my theorems that I just had. I can show that opposite sides are congruent. I can show that the opposite angles are congruent, which for this one actually I cannot do that. I can't do angles because they give me coordinates on this. I can show, like 8, 9, that the one set of sides are congruent and parallel, or I can actually show that the diagonals bisect each other. So I do have some multiple options here. On this particular setup, I'm going to show 2 sides, and I'll do it quickly. But I'm going to show congruent sides here, so I'm going to put congruent sides. And I'm going to split this in half, and then I'm going to do parallel sides. And there's my shorthand knowledge, or shorthand notation for that. If I do the congruence, that means I'm referencing the distance formula. I'm going to write that down right here. And remember they're x1 and x2, y1 and y2 for my formulas. So if I do KL, I got a hair on my thing. If I look at KL, I'm going to kind of write this kind of small so I can put my calculations here. Doing from K to L, my x's are going to be 2 minus 4, as well as 2 minus 4 again. I'll put this in my calculator. I'll clear it out. I'm going to do my square root, parentheses, 2 minus 4 squared plus 2 minus 4 parentheses squared, so I have it all there. And push enter, and I have basically 2.8. If I do my next distance, I'm going to go with LM. If I look at LM, that would be a 4 and a 6. And then the y coordinates is a 4 and a 0. And I want to type those in my calculator. 4 minus 6 squared plus 4 minus 0 squared. And that basically gives me 4.5 as a side length, with a little bit of rounding taking place. And then let's do the distance of MN. The x coordinates are 6 and 4. The y coordinates are 0 and negative 2. And put that in my calculator. 6 minus 4 parentheses squared plus 0 minus negative 2 parentheses squared. So I have that entered. And that gives me 2.8. And I'm going to do my last loop. If they're going to the end, so that means I have to wrap back to the front. So I'm doing KN. Alright, the x coordinates are 2 and 4. And the y coordinates are 2 and negative 2. Put that in my calculator. I have 2 minus 4 parentheses squared plus 2 minus negative 2 parentheses squared. Putting that in my calculator and trying to get that out of the light. And that gives me basically 4.5 again. So if I'm looking at my numbers, I can say that LK is congruent to MN. And I can also say that LM is congruent to KN. And knowing that opposite sides are congruent, that shows that this is a parallelogram. Now, if I switch it and say, okay, I want to do parallel sides. Well, parallel sides means I'm dealing with slope. And that means I have to do y2 minus y1 over x2 minus x1 for all my sides to show parallelism. So if I take the slope of the first one, which was LK, I'm sorry, L or KM or LM, whatever. The y's I'm going to take 4 minus 2 on top and 4 minus 2 on bottom. That gives me 2 over 2, which is 1. If I do the next one, it would be LM. I have 0 minus 4 and 6 minus 4. That gives me negative 4 over 2, which is negative 2. If I do the slope of the next points, that would be MN. That would be negative 2 minus 0 and 4 minus 6. That's negative 2 over negative 2, which is 1. And then if I do the last one, which you have to wrap the first and last points, that would be K and N. Alright, the y-coordinates, I'm going to do negative 2 minus 2 and 4 minus 2. That gives me negative 4 over 2, which is negative 2. So I'm going to squeeze it here on the side. That means that LK is parallel to the other one that has the same slope, which is MN. And then I can say that LM is parallel to the negative 2, that is a KN. So since I have opposite sides being parallel, this could show that this is a parallelogram. So there's actually two ways based on what they ask you to do. So this is the sides, you use distance formula. And the other one, where's my other highlighter? If they reference showing that the sides were parallel, you have to show the sides parallel using the slope formula. There's your two options. Okay, example 3 says find the value of x. And the rest of that actually said find the value of x for which it shows that PQRS is a parallelogram. Well, that's basically just saying find x. And if that's the case here, notice this is on the diagonal, and I know up here for it to be a parallelogram, the diagonals must bisect each other, which means they are congruent. Therefore, I'm going to take 5x and set it equal to 2x plus 9. Subtract 2x, that gives me 3x is equal to 9. Divide by 3, and x equals 3. Okay. Page 29, I have two practice problems. I want you to pause and then work the problems. Then you can start it again and see what the answers were. On practice problem 1, this is a lot like my example 3, where your segments are on, or your expressions are on the diagonal. So that means I'm going to solve this by doing 3x minus 11 will equal x plus 5. There's an understood 1 in front of that x. So I'm going to subtract the 1x. And that gives me 2x minus 11 equals 5. I'm going to add 11. Gives me 2x is equal to 16. Divide by 2, and x is equal to 8. On number 2, it is pointing to two consecutive angles because they're side by side. Consecutive angles, remember, that means, consecutive angles equal 180 degrees. So I'm going to take the x plus 1 and add the other one, 5x minus 7, set it equal to 180. Well, I'm going to combine like terms, so 1x plus 5x is 6x. And 1 minus 7 is a minus 6. I'm going to add 6. That gives me 6x is equal to 186, and divide by 6. X is equal to, looks like 31 if I did that in my head correctly. Divided by 6 is 31. There you go. If you got both of these correct, then give yourself a smiley face. Showing that you did a good job.